let's do a real quick recap of where we just were. And I'm talking real quick, like a minute. This is a slide you already have. You've got this in your schedule page. You can download this bad boy. We have been talking about averages and standard deviations. We're about to realize why those aren't always the best things to talk about either. They don't always give you a complete picture of what's going on. We'll see why. We'll see why. Michelle's already going, wait a minute, damn it. You just told me that if, big if, we've got a bell curve, we can use average standard deviation, get percentages, but then I come back with, what if we don't? And then you're like, oh yeah, okay, what if we don't? So we'll get into that. We'll get into that today. But this is really, if you think about the past week we've spent, or 2 weeks if you go all the way back to center, this is where we are. We've looked at a sample average and a sample standard deviation. What is the sample average? What is the sample average? Define to me, if you give me a sample average, a number that is the average of a sample, what is that number talking about? In your own words. You don't have to use mathematical words. I know what it is. You add them up and divide by how many there are. But what is that? What does that mean?
Like a sample versus the population average?
Not even that. Just what is an average? Like what is an average representing? What is the concept of an average?
To show on average how many times something is going to occur within a group of people.
Right, but what does the word average mean to you?
You have to get rid of that, the definition.
Right, but what does the word average mean to you? Tell me your name again.
Haley.
Haley, why can't I stick that in my mind? Haley, what does average mean to you? Like, give me a phrase when you think of average. What do you think of? Do the math. Good. Do the math. I like that. That's a good answer. Do the math. Damn it. Haley, do the math. Go.
It's not the highest or the lowest, but it's in the middle.
Okay, so middle is a good. That's a good way. It's a middle value. It's a middle value. Taryn goes with.
It's something that you have to equally distribute among how many things.
Good. It's an equal distribution of resources. It's the amount everybody would get if the sum total of the resources was spread evenly. I like that. Ties with middle very nicely. Good. Somebody verbally said the balancing point on the cookie tray. Somebody's used that the other day when you have a graph. When you have a graph, you can visualize where it is, where the balance point would be. Very, very good. Very, very good. What's the standard deviation? Faith, go!
The playroom on either side, give or take for that.
Oh, I like the give or take. Okay. I like the give or take. Can we firm it up a little more? I love the idea, though, of give or take. We taught 105 give or take today. They kind of were like, oh, this is cool. This is cool. I can believe the news now. Scott?
1 unit from center, plus or minus.
Okay, good. A plus or minus a unit, a set of units from center. So S is going to be a number. Whatever that unit is, it's that far from center. Give me the formal conversational definition we established in class together. Do you remember?
Average
Hint, hint. Go.
Average distance.
The average distance of the data from the average, right? This guy has to be paired with this guy. By himself, he's meaningless. By himself, he's meaningless. When you say the standard deviation is 2, your next question is, from what? Right? I mean, what if Ernie had his little tight little standard deviation of 1.6, but his average was a 12 out of 100? He's super consistent. Yeah, and he super sucks too, because he's plus or minus 1.6 from 12. Right? So you look at standard deviation without an average, it's like shooting at a target. You're shooting at a bullseye downrange, and you've got a super tight cluster that's 18 yards away from where your bullseye is. You're super precise, but you're not getting anywhere close to what you're actually shooting at. So that's why you have to look at this and this. Is that fair? Is that fair? Average distance of the data from the average. I love that. And the average, however you want to think about it. Haley, do the math. Kelly, the middle. Taryn, spread it out equally. I like all those. I like all those. Now, I threw up some symbols just to compare and contrast. These are what we are generally going to be dealing with in this class. We will eventually shift to this, not today and not even in the next couple of weeks. But mu and sigma are the symbols used in the journals, in the publications, in the other textbooks for the population measures of average and standard deviation. There is a standard deviation of a population, and there is also a standard deviation, there is also an average of a population. You usually don't know it, though. That's what 105 figured out today. I pulled a Gallup poll. Somebody said, what about a Gallup poll? I'm like, what about a Gallup poll? I threw a Gallup poll up. How worried are Americans about government's ability to deal with Ebola? Are you sick of hearing about Ebola yet? Maybe.
Sick of it.
Interesting statistic somebody penned across my Facebook page. More Americans will be dumped by Taylor Swift this year than will contract Ebola. I thought that was absolutely brilliant. Absolutely brilliant. I mean, that puts it in perspective, and it brings in the idea of why are we hearing it so much in the news, and that brings up another discussion. But the idea is that Gallup and all these news reports give you percentages. You know this, right? That sound extraordinarily precise. It's 64%, and by this point, you know it's not. It's 64% plus or minus something. Yes, you've learned that well. And hopefully you're getting a bit of a feel for that plus or minus, this idea, this guy right here, this plus or minus, that has to be applied to any reported statistic. Good. That's where we were. That's where we were. I'd like to go further. Because Michelle was asking me already, wait a minute, why isn't this enough? Like, why is this not good enough? Well, let me give you an example of why I think it's not good enough. And here's why. And it's all about my boy. It's all about Max. He's 7. He just turned 7. He's huge now. He's huge. But what happened at his 2-year-old checkup?